what is it that you can do on a daily basis to assess current fire danger and future fire danger? Let's first talk about site-specific assessment. So we're talking about at individual mesonet sites. First step is to choose a close mesonet station to your area of interest whose relative greenness best approximates the current greenness levels of your wildland fuels. And we kind of talked about that in the last several presentations. But so example, if you were again in the Marshall area and you were in the fire department, this was in September, you probably would want to choose one of the Payne County stations to represent the wildfire danger in your wildland fuels at that time of year. So for whatever selected station you then choose based on the relative greenness value, at that point, then you can choose the fuel model which best fits the fuel complex you wish to model. And normally you'll use one of these 5 fuel models below. But there's 4 other fuel models available listed here. And by the way, I should mention, because those of you who weren't here yesterday, these presentations, the PowerPoint slides they're already on the Contacts and Learning Tools page of OK Fire. So you can access these as PDFs to look at later. So once you've chosen your station and set the fuel model, then some of the things you would do is look at the current conditions. So you could go to the home page, and in this case, we're using Stillwater Model T, and then you can see the fire weather conditions. You can also see the fire danger conditions. Again, this map here for burning index is based on the default fuel model, which in this case is the same as T, which is what we've chosen. But just know that if you change the default fuel model, then the values here for these 3 components will be different than what the burning index is showing there. But then you could also look then at forecast conditions, charts, and tables, see what's expected for relative humidity and wind speeds over the next 84 hours. You could do the same for burning index, plot that forecast chart. And again, as we showed earlier, you look for days that stand out as compared to the next 3 days. That might be red flags for you. And then also periods of time where it's continuously over a value of 40, which would mean you'd be having problems at nighttime even. But you can also use maps, and they're very important as well, as I said earlier. Some of the National Weather Service maps that are available are in this left menu section. If you go to Fire Advisories and Outlooks, there's 4 maps that are produced. First one is what's called the Fire Weather Advisories map. They can either show here a fire weather watch, a red flag warning, or a dense smoke advisory. Fire weather watch is put out earlier than a red flag warning. So fire weather watch would maybe come out a couple days before a red flag would actually be issued. But that shows you where the Weather Service thinks that there's going to be problems. Then the Storm Prediction Center, which is based in Norman, they have a day 1 and day 2 fire outlook, and they outline where they think critical and elevated fire danger is to occur. So, and this is day 2, so that's also available. Then you could also look at our maps of fire weather variables, such as relative humidity and winds, wind speed and direction. Look at our current maps of fire danger. In particular, things I would look at would be the 1-hour dead fuel moisture, then the burning index map. And again, this is just for the current time, but then to see in the future, you can animate the forecast maps for like relative humidity and winds, wind speed and direction, 1-hour dead fuel moisture, and burning index to give you a good idea regionally around your area what's expected to happen. So let's do a specific example of this, and let's use the Ray Fire as an example. This was April of 2018. And here again with the infrared, this was the 5 days after the fire broke out, April 17th. So here's the fire area as denoted by the satellite. Again, low values of relative humidities, quite strong winds. So let's say we were a fire department fighting this fire. How would we go about using OKFire to look at both current and future fire danger. And in particular, if we want to use a Mesonet site for our chart and table products, how would we go about, choosing that Mesonet site? So the first step would be to choose the closest Mesonet station whose relative greenness best approximates the current greenness levels of your wildland fuels. Well, if you look at Dewey County here, most of the colors for the relative greenness are in this area right here, the browns and the reds. So this 44% stands out as an unrepresentative value because it's probably being influenced by winter wheat fields at this point in time, as are all these other areas. So you definitely would not want to choose that station, but since ceiling is not only representative greenness, but it's also the closest one to the fire location, you would choose ceiling as being representative of the fire area based on both proximity to the fire and also its value of relative greenness. So at that point, then you would say, what fuel model do I want to use with ceiling? So normally you would use, again, one of these 5 models. So let's look at the default fuel model map, and you see that ceiling is model A, which is, again, for agricultural areas. It's not a wildland fuel. It's not a good wildland fuel unless you were actually in the shortgrass area way out in the western panhandle. But for this area, you can see there's a lot of yellows, which is model T. The area where the fire is mainly in the yellows. So I would at that point switch the model at ceiling from A to T to best represent the wildland fuels in the fire area. So then what you would do is go to the home page, choose ceiling as your primary station. Notice that the default is A, but I can change it here to model T. So I would do that at this point. And so that's how you would set up the situation. And then you can go to all the different locations to look at current fire danger and forecast fire danger. And while this is actually a past chart, let's pretend that it is actually a forecast chart at the time for the ceiling station. And you can see that the humidity is expected to rise and then drop down again the next afternoon. Winds are expected. Evidently a cold front was coming through, or cool front was coming through at that point in time, switching winds from the southwest to the northwest. So if you were fighting a fire at this point in time, you would know that your fire direction is going to be changing later that evening, later Tuesday evening. And so you need to be prepared for that because your flank fire is going to become a head fire at that point. So you can look at things like that. And then you could plot, for example, burning index and spread component for model T and see what the behavior is expected to be over the night time period and then the next day. So based on this, what actually happened, you can see that wind switched from southwest to northwest. And I want to show you this perimeter diagram, which we talked about yesterday. This was April 17th, where they were having southwest winds. And so you can see it did bring the fire up more toward the north. But then when the cool front came by and it switched to west to northwesterly winds, it brought some of this fire into this area and even crossed the highway and got into this area with that northwesterly winds. And I gave a workshop in Woodward, I think the fall after the fire, and I took these photos as I was driving the car. Not a very safe thing to do, but anyway, you could see how it totally burned out these hardwood trees when the fire crossed the road. It was, really big fire in the hardwood canopies there. So that's what happened on that day when that front came through. Now, before we begin this group exercise, I want to show you where you can find that in the Contacts and Learning Tools section. So if you click on that and then scroll down to lab exercise number 2 and bring that up, you'll see on the 3rd page here, this is the group exercise that we're going to be doing it. And these are the steps that you can do on a daily basis for determining fire danger in your area, current and forecast. So that's the group exercise we're going to do there. So let me get that out and go back to the home page here. So, and I've already predetermined a really good example to use, and that's, let's pretend we're either emergency managers in the El Reno area or a fire department in the El Reno area. And you'll see why I've chosen El Reno when we get to that point. So first thing would be to choose a nearby mesonet station that has a greenness level appropriate to your native surface fuels for this week. So if we go to our relative greenness zoom map and then zoom in and go to El Reno, you'll see that El Reno is certainly not representative in terms of greenness of that county. There's all sorts of reds and oranges around it, and this is likely being influenced by a winter wheat field near the tower area. So if you were a fire department in El Reno or emergency management in that area, you would not want to use the El Reno mesonet site with the chart in the table fire danger products. So you would want to choose a nearby station that has a greenness more representative. So if I were there, I would choose the Yukon station, which has a value of 6% greenness. So then station I'm using for this example will be Yukon, even though I'm, based out of El Reno. So then we go to the home page and we can set our primary station as Yukon because that's the station that we'll be using. And let's get rid of Marina since that's not anywhere near Yukon. Okay, so then the second question is check the default fuel model for that station, and if you don't like it, change it to a different fuel model. Well, lo and behold, Yukon has a fuel model of A, and that's certainly not representative of the wildland fuels in that area. In fact, if you go to the default fuel model map and zoom in, you'll see that the beige here is kind of the agricultural areas. That's why Yukon has must be close to one of those and has model A, but there's a lot of yellow here, which is model T. So to be more representative of the wildland fuels in that area and to predict fire danger correctly, you'd want to change from the default fuel model A to T. So the way you would do that, again, go back to the home page and then down here, because this is the primary station now, you can change it right here on the home page. You can go select model T, and then it says using alternative fuel model, and it will remain this way until you decide to change it again, whether you leave your browser or not. And you can see it's now changed from A to T. So fuel model now I'm using. So what we're doing, we've chosen Yukon and we've changed the fuel model from A to T. So what do we do at this point? Well, let's look at on the home page some of the current conditions at Yukon. Let's look at first the weather variables. You can see the humidity is 37%. The RH has not changed appreciably in the last hour. Winds are northwest at 15, gusting to 22. We go to the fire danger conditions. And again, this is based on the new fuel model. This burning index will be based on the default model A, which in this case you can see is showing 29, but after we've switched to T, the burning index has jumped to 52. So that's why A was not a very good representative fuel model for the area. So you can see right now for the El Reno area, burning index of about 52, which is in the high category, spread component of about 36 feet per minute, ignition component of about 17%. So now one of the things we can do is look at the forecast charts. Go to that page. And then let's first look at the standard weather mediogram here. So we've already selected Yukon now because that's not a primary station on the home page. Notice we've changed it from the default model fuel to T now. So we get our data. This is, again, independent of fuel model, of course, but it shows kind of the up and down behavior of relative humidity. It lowers again tomorrow afternoon and lowers again Saturday afternoon, and then it's a little higher on Sunday afternoon. Wind speeds are fairly strong still tomorrow. They not quite as strong on Saturday. So when we do go to the BI chart, forecast chart, I would suspect Saturday would have the least BI of these 3 days, because notice how the winds pick up again on Sunday afternoon. So you can look at that, and then let's go back here and look at some of the fire model output predictions. Let's just look at burning index at Yukon using Model T. So as I thought would happen, fairly high index tomorrow. Again, drops on Saturday, but notice there's still a good number of hours where it's above 40, and then it gets a little higher on Sunday. But so you basically need to be on the alert all 3 of those days. But based on this, Friday afternoon would be the one in particular, perhaps to look out for. And then you can do other things like plot the spread component and BI. You can see the spread component on Friday goes up to about 70, let's see, what is it? About 74 feet per minute, which is the highest spread rate of those next 3 days. And then you can look at, for example, the 1 in 10 hour dead fuel moisture prediction here, which again is independent of fuel model and greenness. But you can see the day-night behavior in the kind of stable weather regime that we're having. So then the final question in the group exercise says, based on the information above, what would be your fire danger outlook for this geographical area over the next 84 hours? Well, to best do that, I go back to the burning index prediction. And of course, using the weather information, you can tell, which periods will have what wind directions and so forth. But just in terms of fire intensity, that's what burning index is for. You can see that there will be periods of high fire danger over 40 over the next 3 afternoons. Friday will be a little bit worse than Sunday, and Saturday will be the best of those 3 days, although there's still times on Saturday where there could be high fire danger. But then the good news is that the intensity of the fire would drop as we get towards sunset and the overnight hours. So you get much lower burning indices during these periods. And the spread rates are not particularly high. That they would be the highest on Friday. So that would be my sort of fire danger outlook if I were in the El Reno area. That's how you would go about doing that. So at this point, I'll open it up for any questions on this, if you understand how you can do that on a daily basis. And actually, this doesn't necessarily have to be done on a daily basis. I mean, once you set your station based on your greenness, the greenness really doesn't change that dramatically from day to day. So if you choose an alternative site to use, like in this case, Yukon, you could probably keep it on Yukon until according to the relative greenness map, you see it, El Reno changing to a more representative value, which it probably won't for a long time, because if it's a winter wheat field, it's going to be green for quite a few months going on. So you could keep it at Yukon for a long time, and then changing from Model A to T, that would be a one-time change too. You wouldn't have to keep doing that every day. So once you've set up your system, then you could look at your chart and table products every day without having to make these station or fuel model changes.